Hello everyone, you're welcome back once again. My name is Victor Gomo here, and in our class today, we are going to be looking at another question. We are still looking at angles of elevation and depression. We have before now been able to look at so many examples. So I trust God that when you check out on those examples, you'll be able to see the nature of those questions and their uniqueness so that you can be able to learn those other questions as well. Alongside with this one, I want to take a look at. Before then, I want to thank those of you who have been able to subscribe to the channel. I want to show my sincere appreciation to what you have done. Please, if you have not been able to subscribe to the channel, I say you have to do that because of two reasons. One is that when you subscribe to the channel, you'll be able to access over 100 classes we've been able to do online across many O-level mathematics. Yes, you have done a lot of work already. The topics are there. When you check out on them, you see them. And then the second is when you subscribe to the channel, you are being of an encouragement to us. You are just telling us that what you are doing is good and you like it. So I want to thank you because I know you are going to subscribe to the channel. Thank you so much for doing that. All right, right now let's look at this question. Is another question that has to do with angles of elevation and depression. As I said, he says, I'm going to put it up here as I read from here. This question says, from an aeroplane in the air. So as I am reading this now, you begin to create the imagination. That is what you're going to do when you are looking at it in the question paper. Okay. So from an aeroplane in the air and at a horizontal distance, horizontal, do you get that now? Horizontal distance of 1050 meters. This is Waec question, in the past. 1050 meters. The angles of depression of the top and the base of a control tower at an instance are 36 degrees and 41 degrees respectively. Calculate, let me leave this calculate part and get because the first thing you do is you draw the diagram. The diagram will capture the information, and it is important your diagram captures the information, because if it doesn't, it then means the calculation you are doing possibly is going to be wrong. So let's look at something like this. This pilot, woman or man, is up there and is looking at a control tower. He or she is looking at a control tower. Looking at a control tower. Okay, let this be the control tower. This is a control tower. So something is going to be the horizontal line they are talking about. That is 1050 meters. Okay, yeah. So can I have something like this? Can I have something like this? All right. So this man is looking at the top and bottom of this control tower. So we have to put up another line again to join the bottom, the base of this control tower. So this is the base of the control tower, and this is let me label here capital T, and somewhere here M, and somewhere here N. Okay. So and then is there any other thing I need here before I keep this ruler? All right, what again am I looking for the question paper to capture some other information? So we were told that the angles of depression of the top and base of the control tower at an instance, so the first one is 86 degrees, and for the base of the control tower is, there is an extension here. If you reach 36, you keep on going and you have 41. So if I ask you what is the difference, you should know that what is here should be 41 minus 36. Okay, so that is what should be here. or you can put both of them together and write 41 degrees. Okay, so you have known that this angle here from this line to this line is 36 degrees. That's the angle of depression there. And from this horizontal line to this line to the base is 41 degrees. So it's good you differentiate between the two so that your calculation will not have issue. Is there any other information they have here? Okay, calculate height of the control tower, shortest distance between the aeroplane and the base of the control tower. So, do you realize that in solving this problem, I will say, let me label here. I've started using, let me label here capital P, the position of the aeroplane. Aeroplane. That's the position of that pilot. Okay, and then this is the top of the control tower. Top, top of the control tower. This is the base. Base. I think that's enough. So I will say now you start checking from where you can be able to start handling this question. You get that? So I want to start handling this question from this triangle. So I will say from triangle, how will I put it now? MTP. MTP. From triangle MTP, you know, if this angle 36 degrees is our reference point, this will be the opposite, this will be the adjacent. And the ratio of the opposite side and the adjacent side will give us the tangent of that angle. So we are going to say tan 36 is equals to EM, that is opposite over adjacent, PT. So tan 36 degrees is equals to TM. Can I call this T? Let me use T. I can call here X, but let me just continue with it. TM over PT, which is 1050, okay, in meters. So do you realize that if I cross multiply, I'm going to have this times this will give us TM equals to 1050 tan 36 degrees. So it then means that TM is equals to yeah, I may get the actual value or I may decide to leave it like this. Let me leave it like this for now and check some other things down here because I am sensing something. I will also say again, look at this big triangle, the big one. I used MTP. Let me use here NTP. I will say from triangle NTP. Okay. The same thing happens again. Do you realize that from that triangle, that the whole of this TN is the opposite with reference to this angle 41 degrees, and this PT is the adjacent. So we are still maintaining the tangent of that angle 41. So I will say again, tan 41 degrees is equals to the opposite now will be NT over PT. So this will be tan 41, so I did there up here, equals to NT over PT, which is 1050. I will cross multiply. I will say cross. I'm sure you see cross multiplying. Cross multiplying. So here will be that value n t equals to 1050 tan 41 degrees. Okay. Now, do you realize that what we need here is mn? We need this mn according to the question that says height of the control tower. You get that? The height of the control tower is mn. But there are some things I need to describe here now. I will say note that nt is a combination of nm plus mt or tm. Do we get? So it then means that what we are looking for, which is this nm, what we are looking for is equals to this minus this. That is nt. Okay. I, I'm sure it's not causing any problem. This just like collecting the like terms. So we remove tm, remove tm, and you know that tm is already here. So it then means our nm is equals to, what is this now? Nt is 1050 tan 41 minus, what is tn? That is tm. That is 1000. Can it enter here? 1050 tan 36. Tan 36. Let me write it where you get what I'm saying. This is nm. Okay. nm equals to 1050 meters. Sorry, let me tan 41, then minus, sorry for this, tan 41, then minus 1050 tan 36 degrees. Okay. So if I like, I can factor out this and this. If I like that, otherwise I can just get the value of this, and take the subtraction. But I trust God that this explanation I gave here is very, very clear. Let me not, take time, but I just believe you were able to capture what I was explaining there. So if we continue, we are going to have 1050, then in bracket tan 41 degrees minus tan 36 degrees. So that's what is going to happen there. And tan 41 degrees, tan 41 is equals to 0.8692, 150 bracket 0.8692, 8692 minus 1036, and 36 equals to 0.7265, 0.7265, 7265. Okay, so just trying to make sure that there's no mistake. The difference, I have 0.8692, 8692 here minus this result I have here. That gave me 1050 in bracket 0.1426. 1.1426. I think I could have made an approximation, but let me just leave it. Okay, so times 1050 11050 equals to, that is 149.79. 149.79. 149.79. Did they give us any instruction there? You have to check. Calculate, correct to the nearest meter. So that means this to the nearest meter is approximately 150 meters. Do we get that? So the second question is the shortest distance between the aeroplane and the base of the control tower. We have been able to, yeah, we have been able to calculate here to be 150 meters. Of course, calculating here is not a problem. I'm trying to touch all the corners because I don't know where the question you are going to be faced. Don't even expect them to give you exactly this question, because I can just change one or two things here within here and it becomes another question altogether. So you try to reason fast and you try to open your mind to think wide, so that if there are changes here, one or two changes here, you can still be able to maintain some balance and answer your question. All right. The next question they asked us there is to calculate the shortest distance between this pilot here and the base of this control tower. Assuming something, you know, have to move down, straight down there, you can calculate that. So, are you seeing this line PT? Are you seeing this with reference to this angle? You can see that if I am talking about this angle here, if I'm talking about this angle here, and PT and PN, because this will be adjacent to this and this is hypotenuse to this in that triangle. So if you look at the two, you realize that we are going to be using a cosine of this angle to obtain that. I believe you understand what I'm saying. So in the second eye, distance between the pilot and the base of the tower, the base of the control tower, I will be using cos 41, which is equals to adjacent over hypotenuse. Do we get that? So cos 41 is equals to, did you expect me to say from triangle? The triangle we are considering is this big triangle. From triangle, you can put it there, from triangle NTP. Is there any place I described that NTP? From triangle M, okay, it's the smaller one I described here, not the big one. Okay, let me continue. So I have here cos 41 equals to, the adjacent part is 1050 and the hypotenuse is PN. I'm sure you've seen that line, PN. Look at the triangle I'm considering here. If you extract it, you'll be seeing something like this. Let me do it here. I'm sure you see it here. You see something like this. This is the triangle I'm putting into consideration. This is P, this is T, and this is N, and the angle here now is 41, and this is 1050. That's what I'm putting into consideration. So I'm working on PN now. Do you get? So if if we interchange, we are going to see that by cross multiplication, or let me just interchange this thing. I'm sure you understand what I mean by interchanging. Take this thing, put here, carry this one, come over here. It's still the same thing. So we are going to have Pn if I say over 1 is still what it is, equals to 1050, okay, 1050 over 1050 over cos 41. So I'll check the value of cos 41 so that Pn is equals to, let's say cos 41 is equals to 0.7547. So I have 0.754 what? 7 all over, oh my god, this will be 1050 over 0.7547. Okay, so I will divide, I will now say 1050 divided by 0.7547 equals to, that's 1391. So Pn is equals to 1391.28. But they say to the nearest meter. So this is Pn to the nearest meter is approximately 1391 meters. Okay, so this is how it has gone, and we have been able to examine every corner of it. I trust God that you'll be able to understand the explanation. I don't think there's anything I'm leaving behind here. Please, I don't know if there's still any challenge. The comment section is there for you to put down your question or your comment, and then we can follow up what you said and see how we can also be able to amend what we have done, or follow you up in the challenge you are still having out there. All right, please, this is the question, and I have been able to show us how to handle it. I trust God it has been of help to you, and please, if what we are doing has been of help to you, like it, share it to someone out there, and just on the subscription button, just click on it. That's the way to show us or tell us that, wow, what we did is good and we deserve an encouragement. We have many classes already out there, over 100 of them, so that you can be able to, when you subscribe, access them as well. Please, this is not the last question I'm handling now. After now, I'm going to be taking another example on this, especially for those of you who are Waec candidates. You need to follow us so that you see our development and prepare, because we are consistent. We are very, very strict. We are following the curriculum of Waec examination so that we can be able to prepare you to face that exams adequately. Thank you so much for being there, and God bless you.